Now his speech title is Specification Search, Avoiding and Model Selection. He is an econometrician. He is giving courses related to econometrics and statistics at İbn Haldun University. Hocam, floor is yours. There is no any time limit because I got a permission from Ercan Hocam that we can have more discussion. There is no any time limit. That's why you can start. And I hope you can finish it in 30 minutes, in half an hour. Asad Hocam?
Okay, thank you.
Okay.
Thank you. Can you hear me, Hocam?
Yes, we can hear you. Okay, you can share your slide with us if you want. It's your choice.
Yes, I will share it. Thank you very much.
Okay.
First of all, I will congratulate the organizers for successful organization of this conference. And then we'll say thanks to Professor Ercan and Professor Hassan for inviting me and presenting. This is a literature part of one of my papers, which I am working on with. I'm trying to share the screen.
Hocam paylaş on right above. Okay.
It starts sharing?
Yes.
You can see the screen now.
Yeah, we can see the screen right now. Yes.
And it is slideshow now.
It's
okay.
Small, but it's okay.
It's small?
Yes,
no,
it's not a full page.
Still it is small?
No.
Yes.
It's okay.
Hocam, you can continue. It's okay.
Okay. Okay, there is a common understanding in econometric methodology that if one is interested in measuring the impact of some variable, say X on Y, so one can run a regression of Y on X and some control or auxiliary variables, maybe we call them Z. And these variables, X and Z, which are on the right-hand side, which are the independent variables, they are supported by economic theory. And if the T statistics and F statistic is significant and adjusted R square is high, then one can interpret the model. Now, to provide a hint about this common understanding, I have provided an example of 3 papers submitted to a journal. All these 3 papers have modeled the economic growth. The first model, if we say it is M1, the authors estimated a regression model to check the impact of foreign direct investment and human capital on economic growth. So they ran a regression of log of GDP, means log of economic growth or log of GDP, on these 2 variables, then their interaction term, and an auxiliary variable that is exports. Literacy, LIT, literacy rate has been used as a proxy for human capital. And they found that the T statistics are significant, F statistic is significant, R square is high. So they interpreted the model that these 3 variables, means human capital, foreign direct investment, and exports, they are the determinants of economic growth and they are affecting the economic growth. In the second paper, the authors were interested in checking the impact of intellectual property rights on economic growth. So their research question was about intellectual property rights effect on economic growth. So what they did, they ran a regression of intellectual property rights on economic growth with some control auxiliary variables. And these auxiliary or control variables are economic freedom index, EFW, it has been represented there, trade openness, population growth, secondary years of education, gross domestic investment. And again, the same story. They found the T statistics significant and R square high, F statistics significant, and they concluded that intellectual property rights have a significant impact on the economic growth. And the third model was export-led growth hypothesis. They were testing the export-led growth hypothesis. Now, the question here is that whether all of the three papers means all of the three models are correct, whether it is possible or not. And if we go to the conventional econometric methodology, it says that yes, all of them are correct, because the first model, it is a proper analysis of impact of foreign direct investment and human capital on economy. Similarly, the second paper, it addresses a different question. It addresses how the intellectual property rights are affecting the economic growth. And the third paper, it also addresses a different question. It is export-led growth hypothesis, exports-led growth hypothesis, that how the exports are affecting the economic growth. Now, the conventional methodology results in conflicting and contradicting models, as we can see from those three models. Because M1 says that foreign direct investment, exports, and human capital are true determinants of economic growth. M2 says that intellectual property rights, population growth, gross domestic investment, and some other variables are true determinants. Now, in literature, one can find that there are tens and tens of papers stating that growth is caused by exports. And then there are so many papers which are stating that exports are caused by growth. Similarly, there will be so many papers which can be found that they are saying that there is a bidirectional causality between the growth and exports. And then you can find some papers which are saying that there is no causal structure, or there is no relationship between growth and exports. Now, these are all conflicting and contradictory results. And these are the consequences of conventional methodology. Why it is happening? Because everybody or every researcher is estimating its own regression model and putting a brick in a new and different place. The new researchers or authors, they are not carrying on the work of previous authors or researchers. Therefore, there is no accumulation of knowledge. So, for example, if the first author, it says that foreign direct investment, human capital are the determinants of economic growth, and if he has proved that, and if the M2 author is following the first author, so he may use those foreign direct investment and human capital as control variables, because his question is about the intellectual property rights, but because foreign direct investment and human capital are the determinants of economic growth according to the first set of authors, so he may be using them, but he is not using them. So therefore, everybody runs a new regression and put down a new brick in a different place, and therefore there is no accumulation of knowledge. The Lemur in 1978, in his book, it's a long time ago, he commented on the remarkable differences between the methods taught in textbooks and techniques used in policies, practice in econometrics when you are using. So he says that he was doing PhD. He was a graduate student in 1960s to 70s, and in Michigan University, and he was saying that that the faculty members, the faculty staff who were teaching econometric methods, when they were teaching us, it looks like a pristine inference, very pristine inference. But when they are estimating the Michigan model, they were estimating a econometric macro model. Then they were not using pristine inference. They were using a lot of searches. So he says that the word specification search in his 1978 book, Specification Searches, it refers to the search for a model to summarize the data in the computer lab or in the computers where the actual work is done, while the theory of pristine inference taught in the classrooms, which presumes that the existence of the model before the data are observed. So even when we are teaching the econometrics, we are saying that this is the model. So even if we haven't observed the data, but we are saying that this is the model. Now, this assumption of a known model may work in an experimental setting, in which there are both experimental controls and randomized treatments. But for non-experimental data that economists routinely use, much of the effort is an exploratory research for a model, not estimation with a known and given model. The very wide model search that usually occurs renders econometric theory suspect at best and possibly irrelevant sometimes. Things like unbiased estimators, standard errors, and t-statistics lose their meaning well before you get to your 100th trial model. These were his words in his book about specification search. Now, there are so many assumptions of the regression model, but I have specified here only about the explanatory variables, and it is that they should be complete, they should be unique, small in number, and observable. Now, if we go to the first assumption, that is the completeness of the model, then this means that all of the three models are contradicting each other. The first model says that export is a relevant regressor. Then the second model is wrong because it is not taking exports into account. So you can find contradiction, even they are contradicting each other. Now this means that, and if we go in 1991, Robert Barrow, he wrote a review paper on determinants of economic growth, and according to him, there are more than 60 variables which can affect the economic growth or possible determinants of economic growth. So if we do the calculations like this, so then there are 2 raised to 60 minus 1, the trillions and trillions of possible models. And according to Lemur, or according to econometric methodology, from all of those trillions and trillions of possible models, only one is the true valid model. Now the question is how we can find that which one it is from those trillions and trillions of possible models. Now, when you mix a relevant regressor, what it causes the spurious regression. It was first introduced by Joule in 1926, the concept of nonsense regression or spurious regression. So what happens actually, there have been a lot of studies on it, simulation studies and then the real data studies, that irrelevant variables, they become significant because they work as proxies for missing relevant variables, and because there is always a chance of multicollinearity, especially in time series data, there is a high chance of multicollinearity if we are not dealing with the cross-sectional data. So always the irrelevant variables, they will become significant, and because they are actually working as a proxies for missing relevant variables. So if a regression model omits a relevant regressor, then this means that that regression model is not valid, and it will result in a spurious regression. Now, to solve this question, that how we can find from all of those trillions and trillions of possible models, the one single true model, there have been some modeling structure procedures, modeling selection procedures, modeling selection methods or strategies. We can classify them in econometrics into three: unstructured model selection procedures, then structured model selection procedure, and then the third is Bayesian model averaging. So the unstructured model selection procedures, what they do, they estimate all possible models, just like we have seen there that there are 2 raised to k minus 1. So if there are k candidate variables, so there will be 2 raised to k minus 1 possible models. And for all possible models, you calculate R square or adjusted R square, or standard error of regression, or forward prediction error, or these information criteria, a Kaike information criteria, Schwarz or Bayesian information criteria, or Hananke information criteria. And on the basis of these information criteria, you select the best model, that this is the best model which explains the data. Now, there are limitations to these unstructured model selection procedures. First of all, they're usually or routinely not used for model selection. They are routinely used for leg selection in time series analysis or in panel data analysis somewhere. Then even if you are using them for model selection, because if you go to the Robert Barrow study, there were 2 raised power 60, and there are trillions and trillions of possible models. So how we can estimate those trillions and trillions of possible models? Maybe the solution is solved by supercomputer. Then there is another issue that if we arrange all of those models, thousands of models in the ascending information criteria, means at the top the information criteria is minimum, then at the top there will be at least 20-50 models which have approximately same information criteria. So this means that there is very small differences between those models. And this is called that sometimes noise can exceed the signal, because there is so much noise in the information criteria that you cannot get to a true model. Then in 1930s, some of the structured model selection procedures were proposed in statistics, and they were single pass structured procedures: forward selection regression model, backwise elimination regression, similarly stepwise regression, stepwise with forward selection, and then stepwise with backward elimination. And then in 1978 and in 80s, Lemur gave his own model selection procedure. He said his Lemur's extreme bound analysis. Then in 1997, Sly Martin, he gave his strategy, Sly Martin strategy of it is a version of Lemur's extreme bound analysis, but because Lemur's extreme bound analysis is too much extreme, so he tried to relax some of its conditions. Now, all of these procedures have some issues. This stepwise with backward elimination is first. It is much more better than the rest of it, because its philosophy is much better and its algorithm is much better than the rest. Then the second type is multiple path structured procedures, which is also called the general to specific methodology. Now, this general to specific methodology, it is just like stepwise with backward elimination method, because what it does, it starts with the a general model. So what it does, the general to specific model methodology, it uses encompassing principle or accumulation of knowledge. So for example, if we go back to our example that there are 3 models, M1, M2, and M3, then a new researcher is not allowed to go to give a new model, 4th model M4, or you can name it, we can name it as MJ directly. What he should do, first he should survey the literature, and he should find all of the possible models which have been developed for economic growth. And then he says that, okay, nobody has discussed the intellectual property rights, or nobody has discussed this determinant of economic growth. So I will be checking that whether this variable is affecting economic growth or not. But he has to use all of those variables which have been provided by the previous authors. So if he carries out like this, then this means that his model, it is superior to the previous models, because it encompasses, it nests all of the previous models as special cases, and it gives some much more information. But according to conventional methodology, if we go to there, then what he can do, he can regress his variable in which he is interested in on the economic growth, and he can use some auxiliary or control variables. And similarly, if a next researcher after MJ, if he wants to produce MJ plus 1, a new model, then he has to nest the previous all of the models. So this is how the accumulation of knowledge can work. Now, this multiple path structured model selection procedure, which I named as general to specific methodology, or Henry methodology, or London School of Economics methodology, it is actually based on the philosophy of Popper. This philosophy says that that we try to prove that the regression model we have started is wrong. It is a wrong model. And if we are unable to prove it, that it is wrong, then until if we get some evidence that it is wrong, we say that, okay, it works for a while. And it is totally against the conventional methodology philosophy, where we say that the model is right, because we are starting from a known model. Now, if we go to the practical side of the Henry methodology, what it does, it adds all of the relevant variables based on an exhaustive literature review into a one general unrestricted model. So if we go to our example, so what will be our general unrestricted model from those three papers? We put all of the variables into one model. Now we are not giving any more information. We are just encompassing all of those variables into one model, or all of those models into one model. Now this GUM, it nests all of the three models as special cases. You can see that M1 will be B5, B6, B7 to B10, 0, and similarly M2 and M3. And all of these three hypotheses, they can be tested using the simple joint significance test, F-test statistic. Now, what this methodology says that you build the largest possible model by including all of the potentially relevant variables. You include all of the relevant variables. And while you are including all of the relevant variables, potentially irrelevant variables, because you are minimizing the chance of a regressor to be significant because of an omitted relevant regressor. It should not work as a proxy there. Then you check for outliers and adjust them for them. Then this general model goes through a battery of diagnostic tests, which is very important, which is never present in any of the other methodologies. What are those diagnostic tests? Heteroscedasticity tests, autocorrelation tests, structural break tests, normality tests, and so many others they have put there. And if it passes all of those battery of tests, then this is our GUM. This is our general unrestricted model. Then the GETS methodology, it searches multiple paths using a tree search method. And actually, it is a dropping procedure. It drops insignificant variables in a tree form. And at each dropping variable, at each node, when it drops a variable, a group of variable, or a single variable, again, it uses the battery of tests to verify that whether that model is valid or not. And at the end, what you get, either you get a single model in which all of the variables are significant, and the whole GETS methodology can give you a very clear picture that what was happening in the estimation procedure, why it has omitted those variables, and at what significance level it has omitted those variables. And at the end, you will get maybe 2 or 3 contending models, and on the basis of theory, you can select one of them. Now, what is the difference between this conventional and Henry methodology? So the conventional, which is called simple to general methodology, it says that we start with a simplest model. We start with a single variable, or we start with a 2 variables, 3 variables case. And if then there are flaws, then we put additional variables into it. However, what Henry methodology says that we start with the largest model, for example. And if there are flaws, some flaws there, again, we will use some more relevant regressors. Now, the process is different. In the conventional methodology, you are going from simple to general. You are making it more complicated if necessary. If means that the diagnostic tests are not well, so you add more and more regressor. But on the right-hand side, when you are using the general to specific methodology, then you are making the model much more simpler by dropping insignificant variables, and it is a tree search. Now, the conventional methodology, because it is adding variable at each stage, so it faces two problems: a high probability of type 1 error and a high probability of type 2 error. It faces both of the problems. When you go to the general to specific methodology, then there is a very low chances of excluding a relevant variable, because you have put all of the variables into the model, all possible determinants of the model. So then there is a very low probability of type 2 error, and similarly to type 1 error. Now, what is the result? If you go to the literature, it says that most of the times when you are using the conventional methodology, and most of the time means more than 70% of the times, that the regressions are spurious because due to the omitted variable bias. But when you go to the general to specific methodology, then 80% of the times the GETS methodology, it picks the original true model. And it was a study by Hoover and Perez, and I think 2004 or 2014, I don't remember the year now. Now, there are two important remarks here. One is that how we can build a good parsimonious model. So we can use the general to specific methodology, and through the process, we should not treat it like a computer exercise. So when computer is estimating all of those of models, we should have focus that why it is deleting some variables or dropping some variables. And through the process, we should not be deceived by the accidental correlations and nonsense correlations. And we should, the GETS methodology should be guided by the theory, means economic theory at each stage. So for example, if we are saying that how the foreign direct investment is affecting the economic growth in case of Turkey, let for example, Turkey. So if the GETS methodology is deleting that variable at the first stage or at the second stage, now we know that there is a very strong economic theory that foreign direct investment is a significant determinant of economic growth. So we can say to the GETS methodology that keep this variable with you, don't drop it at this stage. But if one just puts a computer exercise, then maybe after, because it only checks the T statistic significance and F statistics and those diagnostic and Betkiov tests, it does not give any regard to the economic theory. So what will happen that maybe at the end, you will not see any foreign direct investment in the economic growth relationship of Turkey. So, and the most important thing is that always prefer theory over empirics. And that is because in economics, we don't have a larger data set, for example. So if you are using the GETS methodology on financial economic data, or where you have a good number of observations, then you can prefer empirics over theory, because then it can it can draw out a good model from the data. But if one have only 50-60 observations, then it's very difficult to draw a model from it. Then we have to prefer theory over empirics. Then the second remark is interpreting the model. So if we are picking some genuine, valid, and stable correlations in the model, in the whole estimation procedure of the model, but they don't justify the causal inference, because the regression models, they are not representing the causal inference. So for example, the same paper which I quoted earlier, Hoover and Perez paper, they identified the percentage of confusion as a significant determinant of economic growth. And they started with, I think, 59 variables and used the GETS methodology, and they found that this confusion percentage is a significant determinant of economic growth. And they tried so many things, but this variable always became significant. Why it is? Because of China, because in that time period, the economic growth of China was so much explosive that this confusion percentage of the population which are confusion became a significant determinant of economic growth. But it is not a causal relationship. This is what we are making a point here. Thank you for listening.
Okay, thank you very much, Dr. Asad. It was very technical. Also, it was very informative presentation. Is there any question from listeners? If you want to ask any question from, okay, I think there is no any question. Hocam, thank you very much.
You're welcome, Hocam. Thank you for having me.
Yeah, for attending.
Irjan Hocam, Özgür Hocam, see you inshallah sometime face to face.
Thank you for valuable participation and contribution. See you again in Istanbul or Turkey.
İnşallah hocam.
İnşallah.
İnşallah hocam.
İnşallah.